Hello, this is Nick here for you today with my third and final unit of my AP Computer Science problem sets set. So today we'll be focusing a little bit on just some classes and polymorphism and inheritance. So we have our first 10 questions using the set of classes bank account, savings account, and checking account, and it's just good to notice that savings account and checking account are extending bank account. So they have all of these methods, they're just like a level lower down. So the first question is fairly simple. Of the methods shown, how many different non-constructor methods can be invoked by a savings account object? So we go up here, we find all the methods that aren't constructors. So this is a constructor, this is a constructor. 1, 2, 3. These are both constructors, but this one can be called as well, so that's 4. So the answer is D. Moving on to 2. Which of the following correctly implements the default constructor of the savings account class? 1, my interest rate equals 0, super. A little problem with this is that super is not the first call. If you don't put it at all, it will be done automatically, but you have to put it first if you're going to put it. So here, this is okay, super, and then my interest rate equals 0. And then 3 would be just calling super in the first place. And so we go up here and we check whether anything is implied for this. It doesn't say anything about it, so it can be constructed however the person wants. So 1 doesn't work because super's in the wrong place, but 2 and 3 work. So C is the correct answer. So for number 3, which is a correct implementation of the constructor with parameters in the savings account class? So my balance equals balance, my interest rate equals rate. So we can go up here and check what the field names are. The bank account is my balance, and then savings account extends it, so it has my balance as well as my interest rate. So we would go back down here. My balance equals balance, that's fine. My interest rate equals rate. So, yeah. For B, get balance equals balance. This is a an accessor. So that's not what happens. So in this one, super, which takes care of my balance. Like in this case, my balance is in the super class, so you should have the super call to have it instantiate itself rather than trying to mess with it in the top level constructor. So for C, it gets super, but the thing is it isn't putting balance into the right place. It's not putting balance in here, even though rate gets in the right place. So then super balance, this is exactly what I was talking about. It gets into the lower level of the class and gets into the right place in my balance. And this is right as well. So the answer is D for 3. 4, which is a correct implementation of the checking account constructor. So super balance, super deposit balance, and deposit balance. So for this one, these all look fine, but we can check up here for the implementation of this. So for checking account, it only takes the balance. So basically, you're just making a bank account in the constructor, but you keep track of these extra final values, which aren't going to be changed because they're final. So yeah, you just basically have to construct a bank account. And that can be done in all 3 of these ways because super is called implicitly before deposit balance. It's called implicitly as the first line in your code. So essentially 3 and 2 are the same thing, and then 1 is the most correct. It just like constructs it in the way that it really should be constructed. So 1, 2, and 3 are all correct, and the answer is E. So for number 5, which is correct implementation code for the withdraw method in the checking account class? So super.withdraw amount if my balance is less than min balance, super.withdraw fee. So we'll just move on to the next one. Withdraw amount if my balance is less than min balance, withdraw fee. So the difference here is in withdraw and super.withdraw. We can go up and check the methods. So A looks fine so far, but I will probably find something wrong with it after I've gone through the rest of them. So yeah, this takes out the amount, which doesn't really make any sense. Wait a second. So the problem is, okay, so the problem here is that my balance, that's a private field within the superclass. So you have to use an accessor rather than just saying my balance. So in this one, it actually does that. It does get balance. And you do need these supers. Otherwise, it won't work out. So yeah, C is the correct answer. As you can see here, this one doesn't use the supers, and so it's not correct. So for number 6, redefining the withdraw method in the checking account class is an example of A, method overloading, B, method overriding, C, downcasting, nope, D, dynamic binding, late binding, and E, static binding and early binding. So dynamic binding, that's like not even related to Java. That is in languages like, let's see, Python. So whenever you put something into an old variable, it just changes the type for you, rather than saying error, it's not the right type. And then static binding is what Java does, just in general with its typing. So you establish a variable type, and then something goes in there. But both of those aren't related to this. So C, D, and E are all wrong. So overloading is when you have the same name all within a method, but with different parameters. So they're slightly different, but they don't really interfere with each other. And then overriding is when you just, in the next level, you make it so that the previous level's method just isn't even used. So that's what overriding is, and that's kind of a description of what's happening in the checking account class. So the method is overrode, and the answer is B.